Good day everyone, welcome back to my channel. Today we'll be using the two-point form formula to devise linear equations. Now, the two-point form formulas are more common in advanced mathematics, especially pre-calculus, but specifically because they require one to be able to be accustomed with gradients. So through practice, especially looking at the gradient or slope of lines, one will actually recommend that one revises all the concepts relating to gradients before actually engaging with two-point formulas. And we need to be able to identify certain key areas with respect to this application. So for instance, that suppose we are to use the two-point formula and we are given two sets of coordinates. For instance, A, at point A, x is -2 and then y is 3, and then B, x is equals to 6 and y is equals to -1. Okay, those are our coordinates that are given. So there's also one thing that I also like to emphasize with regards to this. Now notice with regards to this identity, at point A, we have x2 and then also have y2. That's at point A. Now at point B, we have x1 and we also have y1. Okay, it's very critical to be able to identify these parameters. So moving forward, by calculations, we should now be able to integrate these parameters successfully into our general equation, which goes like this: y minus y2 equals to the change in y over the change in x multiplied by x minus x2 close bracket. That's the general formula for our two-point form application. So now, moving forward, what we need to do now is just to simply substitute the parameters. So we have y minus 3 is equals to 3 minus -1 over -2 subtract 6 multiplied by x minus -2. Y minus 3 is equals to, so we have 3, negative times negative gives us positive, so we have +1 there, over -2 minus 6 gives us -8, multiplied by x, negative times positive, negative gives us positive, so we have +2, y minus 3 is equals to, so 3 plus 1 gives us 4 over -8, multiplied by x plus 2. Okay, so y, so we are looking at the gradient in this case, so y minus 3 is equals to negative 1 over 2, and then by substitution or multiplication, so we can just simply integrate and factorize, multiply the bracket out. So in this case, we gonna multiply. So we have 1 over 2 multiplied by x is a half over multiplied by x, and then negative. So remember, now we have 2 over 1, which gives us simply 2 over 2. Okay, so we have y minus 3 is equals to negative 1 over 2x, minus 1. That's what we essentially have at this stage. So now by substitution, we have y is equals to negative half x minus 1 plus 3 y is equals to negative half x. So negative 1 plus 3 gives us simply positive 2. And then that is the final answer for our given coordinates. So we have actually calculated we've devised the equation using the 2-point form formula for our given points, which is A, where x is negative 2 and y is 3, and then B, where x is 6 and y is negative 1. Okay, so like I said, through practice, one should be able to annotate and devise this application. Now, let's look at another example, the last example for the day. So suppose just tidy up here. Now, the 2-point form formula is relative to our pre-calculus course because one needs to be able to use the gradient point, or rather the gradient form of this application. So basically it will be recommendable to be able to look into using the gradient, or rather to be able to find the gradient before actually engaging with the 2-point form formula. And again, it's very important that one actually recognizes one aspect or avenue with regards to this. It is essential that you keep the order in which you subtract the coordinates of the points the same in the numerator and in the denominator. So if you consider that point, then you should be fine to be able to calculate or rather use the 2-point form formula to be able to devise linear equations. Now let's look at another example. I'm going to actually use two examples from two sets of coordinates. So in this case, we have points. The given points now are, so the given points, the given points are, so we have C. At C we are given where x is equals to 0 and y is equals to 3. That's the point, the coordinate at that point. And then at point D, The coordinates are x is equals to 3 and y is just simply 0. So again, identifying the parameters in this aspect. So I'm just going to quickly identify them there. We have first initial parameter, we have x2 by y2, and then the second denomination we have x1 by y1. It's very important to identify these parameters. I'm just devising these so that we are systematic in our application, most especially because we want to keep and maintain simplicity and order within our calculations. So just to prevent or rather avoid the slips in our mathematics. So in this case now, one needs to be able to, or rather should be able to devise the formula. So the formula goes like this. The general formula rather goes like this. Y minus y2 is equals to the change in y over change in x multiplied by x minus x2 close bracket. So that's our general formula. Very important to consider this. It's very critical that one gets accustomed to this formula, especially when we be dealing with these kind of applications in higher mathematics. Okay, so moving forward, by substitution and integration, so we're going to just simply say y. In fact, let me just use so we have y minus, by substitution, I know that I already have 3, so I'm going to use my 3 is equals to, we have 3 minus 0 over, so we have x2 this time, so x2, our x2 is 0 minus x1 is just simply 3, okay, multiplied by x, subtract, so our x2 in this case, by substitution, we just simply have 0. Okay, now moving forward, we have y minus 3 is equals to 3 minus 0 just simply gives us 3. 0 minus 3 gives us negative 3 multiplied by x. X minus 0, we can just simply maintain it just for orderly, or rather for maintaining order within the bracket. Okay, so we have y minus 3 is equals to, so we just simply have negative 1 already there, so we have x minus 0. So by opening the bracket, multiplying the bracket out, so we're going to have y minus 3 is equals to negative 1 multiplied by x gives us negative x, and then negative times positive gives us positive, and then 1 multiplied by negative 1 multiplied by negative 0, or rather 0 is just simply 0, so we don't have any value there. So you have y minus 3 is equals to negative x. So by substitution, we just simply have y is equals to negative x plus 3. So essentially, notice here we have a silent one here in algebra. So we have y is equals to negative 1x plus 3. So that, in a nutshell, is our equation using the 2-point form formula. Now, one last identity that I like to express is to be able to identify a certain area or domain within this aspect. Yeah, for instance, when we look at this, let me just emphasize or highlight this point here, this one here. Notice we have a gradient here. That's a gradient. Okay, so what it means there, we have y minus y2 is equals to m multiplied by x minus x2. That's what it means essentially. This and that are the same thing. Okay, so one needs to be able to identify that within the scope of practice. Hence, I highlighted this earlier on to say this application requires one to be able to have prior knowledge with regards to be able to work with gradients and slopes on a Cartesian plane, which will be very useful, especially when dealing with Euclidean geometry. Now, moving forward, likewise, assume now we have our gradient. So our gradient now we have -1. Already we saw that our gradient is -1. In fact, let's just establish an application so that we can see how we got that -1. So our gradient is equals to the change in y over the change in x. Okay, so our gradient is equals to, so our change in y over change in x, we have 3 minus 0 over, okay, so we have x2 says 0 minus 3, m is equals to 3 over -3, and in this case it's just simply 1, -1 rather. So that's our gradient. Hence we saw that, especially there is the -1x. So this is very important that one practices this application so that you are able to see how these factors pan out throughout this formula. So thank you for watching. Please drop the comment below so that I can be able to identify certain elements within this scope and highlight when an element needs any consideration, especially when we look at the parts that I'll actually be developing in terms of Euclidean geometry, which is our next component in mathematics. So please like, share, and subscribe to my channel, and we'll meet in other videos. Thank you. Goodbye.